viewers, welcome to CEC Gurukul lectures. I am Dr. Sanawar Soham from Department of Botany, Kalindi College, University of Delhi, and I was discussing various systems of classification. In my previous lecture, I had started with Takhtajan's system of classification, and I will be continuing with the outline of Takhtajan's system of classification now. So, as I told you that according to him, angiosperms were Magnoliophyta. They had been divided into two classes, Magnoliopsida, which were dicots, and Liliopsida, which were monocots. Now, this slide shows the division Magnoliophyta into two classes, the subclasses being two classes mainly Magnoliopsida and Liliopsida. In Magnoliopsida, if we talk of, there were 11 subclasses, as you can see, whereas in Liliopsida, which were considered to be monocots, had only 6 subclasses. I will take these in detail now. If we talk of Magnoliopsida or dicots, it is further divided into 11 subclasses, as I told you, 55 superorders, 175 orders, and 458 families. The estimated genera being 10,000 and species around 2 lakh. Now, these are the 11 subclasses: Magnoliidae, Nymphidae, Nilambonidae, Ranunculadeae, Caryophyllaceae, Hemamelidae, Delinidae, Rosidae, Cornidae, Asteridae, and Lemmidae. If we talk of Liliopsida or monocots, it is divided into 6 subclasses, 16 superorders, 57 orders, and 131 families, which were estimated genera of 3,000 and species 60,000 in number. Now, the 6 subclasses of this group are Lilidae, Commonilidae, Ericidae, Elismetidae, Triuridae, and Eridae. Takhtajan has accepted main divisions and subdivisions as classes and subclasses, almost similar to classification given by Bentham and Hooker. In Hooker's system, the larger taxa are natural since their status is ascertained on the basis of large number of characters. But so far as further subgroupings like series Thalamiflorae, Disciflorae, Calciniflorae, etc., and several orders and families are concerned, one can easily spot out that more or less only one character is chosen as basic criterion in categorization, making it more artificial. Takhtajan introduced modifications at such levels. A critical examination of Takhtajan's classification shows that it is of considerable merit, since he has made use of maximum data available to various fields like morphology, cytology, palynology, anatomy, embryology, cytogenetics, biochemistry, paleobotany, etc. in the construction of taxa of various ranks. If we move on to the merits of Takhtajan's system of classification, the classification of Takhtajan is more phylogenetic than that of earlier systems. This classification is in a general agreement with the major contemporary systems of Conquest, Dahlgren, Thorne, and others. The nomenclature adopted in the system is also in accordance with the ICBN even at the level of division. The treatment of Magnoliidae as a primitive group and the placement of dicotyledons before monocotyledons are in agreement with the other contemporary systems. The concept of primitive flower in the classification is in accordance with the modern taxonomist, and also the introduction of the rank of superorder in the classification has provided an important link between the large subclass and smaller order. If we go about the demerits, in this system, more weightage is given to cladistic information in comparison to phenetic information. Also, this system provides classification only up to family level. Thus, it is not suitable for identification and adoption in herbaria. Takhtajan recognized angiosperm as division which actually deserve a class rank like that of systems of Dahlgren and Thorne. Numerous monotypic families have been created in 1997 due to further splitting and increase in number of families to 592, resulting into a very narrow circumscription. Other demerits are Takhtajan incorrectly suggested that smaller families are more natural. Although the families Winteraceae and Canilaceae showed 99 to 100% relationship by multigene analysis, Takhtajan still placed these two families in separate orders. So, we required a better and more evolved system of classification. Moving on to such contemporary phylogenetic system, if I talk of, during the last few decades, the angiosperm phylogeny group, also known as APG, has been working towards realization of the monophyletic groups. It is the first version of modern, mostly molecular based system of plant taxonomy. The APG system was published in 1998 by the angiosperm phylogeny group for the first time. It was replaced by the improved APG system APG2 in 2003, followed by APG3, which was given in 2009, and APG4 in 2016. The system is rather controversial in its decision at the family level, splitting a number of long established families and merging some other families. No botanical names are above the level of order in this system. That is, an order is the highest rank. The higher groups are defined only as clades with names such as monocots, eudicots, rosettes and asterids. APG4 system appeared in 2016 and superseded all previous systems. Now, if we talk of and compare APG3 system with APG4, APG4 system recognized 5 new orders, which were Borraginales, Dillionales, Icacinaales, Metanuceales and Valiales, along with some new families, making a total of 64 angiosperm orders and 416 families. 2 additional informal major clades, which were super rosettes and super asterids, proposed that each comprise the additional orders that are included in the larger clades dominated by the rosettes and asterids. Another important feature of this was 2 parasitic families, formerly of uncertain position, are now properly placed, that is, Cynomoriaceae in Saxifragales and Apodentheaceae in Cucurbitales. Now we will discuss the principles of APG's approach to classification. The linear system of orders and families should be retained. The families is central and flowering plant systematics. Now groups we have to make should be monophyletic, that is, should consist of all descendants of a common ancestor. The main reason why existing systems are rejected is because they do not have this property. They are not phylogenetic. So, a broad approach is taken to defining the limits of groups such as orders and families. Parallel to the level of orders and families, the term clade is used more freely. So, the existing systems are rejected because they are not phylogenetic. The APG system showed that the monocots form a monophyletic group, a clade, but that the dicots do not. So, they were considered paraphyletic. Nevertheless, the majority of dicot species do form a monophyletic group called eudicots or tricolpates, which basically were making up 75% of the dicots. Of the remaining dicot species, most belong to a third major clade known as Magnolidae, containing 9,000 species. The rest include a paraphyletic group species known collectively as basal angiosperms, plus the families Ceratophyllaceae and Chloranthaceae. If we talk of eudicots, as I told you, which was one of the major clade with having approximately 75% of angiosperms, they are a clade strongly supported by molecular data and comprise bulk of angiosperm species. This large clade is supported by a single morphological synapomorphy with triaperturate pollen. Now, this pollen type is unique to the eudicots, and while not all eudicots have triaperturate pollen, pollen is clearly distinct from the uniaperturate pollen of basal angiosperms, monocots and all other seed plants. The fossil pollen record indicates that the eudicots appeared 125 million years ago, shortly after the origin of the angiosperms themselves. This slide shows the interrelationship of the APG4 orders and some families. I will be taking up these part by part in my lecture. Now, APG4 system does not incorporate completely extinct groups such as the proposed angiosperm family Archifructaceae, which includes the fossil genus Archifructus from the early Cretaceous of China. Nevertheless, APG4 classification adequately covers enough angiosperm diversity in the fossil record that its use is not a major impediment for paleobotanists. Angiosperms include over 3 lakh living species of plants. Although division of angiosperm tree into clades for the purpose of classification is somewhat arbitrary, roughly 8 major groups can be recognized under the APG4 scheme. 2 of these, the monocots and the eudicots, represent the vast majority of living angiosperm species, while the others are relatively small groups. Some of them are well represented in the fossil record and important in the early history of the angiosperm evolution. Now, this slide shows the overview of 8 major groups which can be recognized under the APG4 system. You can see there are 8 major clades here. I will be taking up in this next slide. The name ANA grade, ANA grade, is used collectively to refer 3 basally diverging groups of angiosperms, where A stands for Emborreliales, N stands for Nymphaeales, and another A stands for Austrobeliales. These groups represent a very small proportion of extant angiosperm diversity. Although Nymphaeales and Austrobeliales are represented in the fossil record beginning in the Cretaceous period. Living anagrade angiosperms are significant for helping us to understand some aspects of angiosperm evolution. For example, our understanding of the evolution of the angiosperm megagametophyte, that is female gametophyte or known as embryo sac, is based on the study of megagametophytes in the members of Nymphaeales and Austrobeliales. Now, this slide shows the photographs of anagrade angiosperms. The left one showing Emborrella, which belongs to Emborreliales. The center one is the center water lily Nymphea, which belongs to Nymphaeales, and the right one Florida enstree Elysium, which belongs to Austrobeliales of anagrade angiosperms. Now, moving on to another group or major clade, Magnolids. They are a group of flowering plants, and until recently the group included around 9,000 species. including magnolias, nutmeg, bay laurel, cinnamon, avocado, black pepper, etc., etc. That group is characterized by trimerous flowers, and they have pollen with one pore and usually branching veined leaves. Now, some members of the subclass are among the earliest angiosperms and share anatomical similarities with gymnosperms, like the stamens that resemble the male cone scales of conifers and the carpels found on the long flowering axis. So, this is a flower of Asimenia triloba. Basically, it's a magnolid. The APG3 recognizes a clade within the angiosperms for magnolids, and the clade includes most of the basal group of angiosperms. This clade was formally named Magnolidae in 2007 under the provisions of the Phylocode. So, this slide shows the current phylogeny and composition of magnolids. In this, you can very well see the position of magnolids, and the magnolids are further divided into 4 clades, that is caneliales, piperales, laurels and magnoliales. Now, monocotyledons, if we talk of, or the monocots, this is another clade in APG4 system. So, monocotyledons, as we all know, are commonly referred to as monocots and are grasses or grass-like flowering plants or angiosperms, the seeds of which typically contain only one embryonic leaf or cotyledon. This slide shows wheat, an economically important monocotyledon. Monocotyledons have almost always been recognized as a group, but various taxonomic ranks and under several names. Now, APG3 system of 2009 recognized it as a clade called monocots, but does not assign it to a taxonomic rank. Within the angiosperms, there are 2 major grades. One, a small early branching basal grade, which I discussed, the basal angiosperms or the Ana grade, with 3 lineages, which I told you, and a larger late branching grade or the core angiosperms, which are mesangiosperms with 5 lineages, which are shown in the upcoming slide. You can see here, you can very well see here the cladogram showing the phylogenetic position of monocots within the angiosperms. We can see the angiosperms, as I told you, there are basal angiosperms and the core angiosperms. It has been divided broadly. So, I talked about amborales, nymphaeales and astrobales, which was Ana grade. These were the basal angiosperms. Monocot falls in the core angiosperm group. So, you can very well see the position of monocots here. Molecular studies have both confirmed the monophyly of the monocots and helped elucidate relationships within this group. The APG system does not assign monocots a taxonomic rank, instead recognizing monocots as a clade. The APG system establishes 11 orders of monocots. These form 3 grades: the alismatade monocots, lilioids monocots and commonly lit monocots by order of branching from early to late. Now, this cladogram shows the phylogenetic composition of the monocots, as I had already discussed, the basal ones and the core angiosperms. So, you can see that there are 3 basic groups which I had told about: the alismatids, lilioids and the commonilids. So, here the asimilids, lilioids and the commonilids. You can see they are further branched into clades and classified. Now, of some 70,000 species by far, the 2 largest, that is 65%, are found in 2 families, orchids and grasses. So, the orchids belonging to Orchidaceae and order Aspergales contains about 25,000 species, and the grasses Poaceae, which belong to Poales, consist of about 11,000 species. Other well-known groups within Poales include Cyperaceae family, which are sedges, Juncaceae, which are rushes, and the monocots also include familiar families such as the palms which are known as Ericaceae, belonging to order Ericales, and lilies, which belongs to liliales. Now, if we talk of eudicots, and I had already told you that they basically form the 75% of, or comprise 75% of the angiosperms. So, the eudicots, also known as eudicoti or eudicotyledons, are a clade of flowering plants according to APG system, mainly characterized by having 2 seed leaves upon germination. The term is derived from dicotyledons. Traditionally, they were called tricolpates or non-magnolid dicots by previous authors. The botanical terms were introduced in 1991 by evolutionary botanists Doyle and paleobotanist Hatton to emphasize the later evolutionary divergence of these tricolpate dicots from earlier, less specialized dicots. Numerous familiar plants are eudicots, including many common food plants, trees, ornamentals. Basically, it seems to be a new group, a new clade, but we very well are familiar with such plants which belong to eudicots. Some common and familiar eudicots are sunflower, dandelion, forget-me-not plant, cabbage, apple, buttercup, etc. Most leafy trees of mid-latitudes also belong to eudicots, with notable exceptions being magnolias and tulip trees, which belong to magnolids, and ginkgo biloba, which is not an angiosperm. Now, this is a flower of Senecio angulatus. It's just an example of a eudicot. Now, the eudicots can be divided into 2 groups, the basal eudicots and the core eudicots. If we talk of basal eudicots, it is an informal name for a paraphyletic group. The core eudicots are a monophyletic group. The core eudicots can be divided into 2 clades, Gunneriales and a clade called Pentapetalae, comprising all the remaining core eudicots. Now, this slide shows the division of eudicots, and it is in the form of a cladogram. You can see there are different branches and they have been divided and subdivided based on the latest modern taxonomic classification system, that is APG system. Now, moving on to superrosettes. The superrosettes are members of large clade which are monophyletic in origin of the flowering plants, containing more than 88,000 species, which forms more than a quarter of all the angiosperms. You can see the photograph of Euphorbia heterophylla, which is basically placed in superrosettes. Now, the clade is divided into 18 orders as defined in APG4 system, and these orders in turn together comprise about 155 families. The name is based upon the name Rosidae, which had unusually been understood to be a subclass. Now, this is basically the cladogram showing the phylogeny of superrosettes. If we talk of rosettes, they are the members of a large clade monophyletic group, and they contain about 70,000 species. The clade is divided into 16 to 20 orders depending upon circumscription and classification. These orders in turn together comprise about 140 families. Now, this again is a cladogram which shows the phylogeny of rosettes and their diversion and points of diversion and branching them into various groups. Now, we will move on to the merits of APG system of classification. The system is based on the sound phylogenetic principle of constructing taxa on the basis of established monophyly. Formal group names have been given mostly up to the level of order where monophyly of the group has been firmly established. If we talk of the traditional division of angiosperms has been abandoned and various monocot taxa are placed in between primitive angiosperms and eudicots, thus overcoming the problem of paraphily in the earlier recognized two groups, the monocots and the dicots. If we talk of Winteraceae and Cannulaceae, which I had referred to in Takhtajan system of classification, they are now correctly brought together under the same order. Their affinities are strongly supported by morphological studies and multi-gene analysis. The merger of Asclepiadaceae with Apocynaceae has been strengthened by molecular evidences in this APG system of classification. Recognition of distinct Asclepiadaceae would render Apocynaceae as paraphyletic. Now, if we talk of two parasitic families, they were formerly uncertain in position and now, because of this classification, have been correctly placed. For example, Cynomoriaceae is placed in Saxifragales and Apodanthaceae is placed in Cucurbitales. Now, if we talk of the demerits of APG system of classification, the classification having not proceeded beyond family level and the system is not useful in practice of adoption in herbaria and floras. Almost most of the orders have been assembled into informal groups. No proper names conforming to botanical code have been given for these groups. Angiosperms have been given the rank of a division, but there are no formal taxa between the rank of an order and division, a rather unusual phenomena for classification systems. So, I would conclude that the new system that is generated during the last 20 years, based primarily on the molecular data, has been a breakthrough in the field of plant systematics, but in my opinion, classifications based on morphology should be continued for herbarium classification, and for theoretical discussion on phylogeny and evolution, APG system can be adopted. Thank you very much.